Hello tout le monde. إن شاء الله يكون الضوء منيح suffisant. شوف إذا بضوي هون. هيدو لا هيك الضوء مش أحلى. هيك الضوء منيح. بدي أشوف إذا عم بتشوفوا هون هلا بشرح لكم شوي عن تابلو. good thank you. هاي جوزاد سالي قلبك. بس رح انطر شوي لحتى يكون في اكتر كونكتيز. ما بعرف اذا بتنقال كونكتيز كونكتد. موضوع اليوم رح يكون عن الاتموسفيريك ويف انرجي اللي عملتها البلاست اوف بيروت. اكيد كلنا سمعنا هذا الخبر عن الانفجار اللي صار ببيروت ب4 آب المشؤوم الذكر، وشو اللي صار وشو اللي تغير بالاتموسفير وشو اللي بيتغير بالاتموسفير and what happened. I will speak in English for the visitors, the foreigner visitors to understand what I'm talking about. And if any translation in French or in Arabic needed, you can ask me if any term is not understood. I will be waiting. Hello, Dave. If any translation is needed, I will be explaining later on. This video will not be so long. I don't want to make it like a conference or something like that. It's just I was asked a lot of questions by friends and family. What is that about? So I thought hello Nabil. I thought about to explain it a little bit. So to start this small explanation, let us talk about the atmosphere. What happened on the atmosphere? So let me just put this here. Okay. So if you see here, this is the ground. Not all the planets have atmosphere, but it happens that our planet, the Earth, which is we have the Sun, Mercury, Venus, and Earth. So the planet Earth has atmosphere, and this is the ground. We have several layers of the atmosphere. We have from the 0 to 12 kilometers, like I'm drawing to you. This is the troposphere. Then we have a separation. The troposphere is an interesting part of the atmosphere. And we have from the 12 to the 50 kilometers, we have the stratosphere. And the tropo means that is changing. And we have the 75% of all the gases. We have the nitrogen, we have the oxygen, like 75% of the nitrogen, 21% of the oxygen. Hot balloons are on the tropospheres. The clouds are formed there. From the 12 to the 50 kilometers, we have the stratosphere. The separation, it's called the tropopause. Then at from the 50 to the 85, it is called the mesosphere, and this is where the hello Carla, this is where the meteor are burned, and the meteor are some small planetesimal small rocky things that they are with the friction they burn and they arrive to the Earth. And we have here from the between the 50 so to the 85, and the separation, it's called the stratopause. And we arrive to the separation from the 85 to the 70 kilometers. We call the sphere, and it is very hot. It's thermo, like a temperature. And then we have, after 700 kilometers, it is the exosphere. Exosphere means that it is so high. It is the like extra. You see that it is, we have several layers between several atmospheres, and the separation between them, it's not so clear. But before several hundred years, we just thought that it is just the 80 kilometers that we know as an atmosphere, and we were not aware of a very important part for the atmosphere, which is the ionosphere. Why it is important, this ionosphere? And the ionosphere is, well, we discovered, not we, but scientists, not I, but scientists discovered that the ionosphere, as its name, well, actually it is kind of here. It's like between the 85 and the 500 kilometers. This is where everything happens with the ionosphere. Ionosphere is always changing. It is not fixed. As its name presented, it's ion. So it's mainly changing because of the sun, of the actions from the Earth, and from the interaction of waves. We call it the wave atmosphere. What is happening is we have some free electrons in the ionosphere. And the density, I forgot to tell you that the density of the atmosphere on Earth goes decreasing, if you want. It is going to decrease, decreasing from the surface of the Earth here until that it will meet the space. So the ionosphere, it is the place where we have charged atmosphere. Charge means that it is ion, it's unpredictable. It is really, it's also a place where we have a lot of satellites. It is disrupted, it's changing. It is glowing, it glows. When we have electrons, so we have exchange of electricity. And we cannot see it at night. And this is, I might tell you, I don't want to go into details, but we have several layers of ionosphere. We have F, we have D, and there is a satellite called Ionosphere Connection Explorer, ICON, that studied more in details the ionosphere. Well, the ionosphere can change thickness from day to night. When I mean day to night, it is when the sun will hit its flares. You know that the sun, it is a nuclear power. It goes to fuse the hydrogen into helium. So it sends its light and its flare and coronal mass ejection to the Earth. It will send it when we are in front, when the Earth is in front of the sun. So we have a lot of excitation of electrons on the ionosphere, and the ionosphere will become thicker. When the part of the Earth is in the night, this ionosphere will become less thick, and so it is thin. So the ionosphere is in constant change, and well, actually this is where the aurora borealis and aurora australis, what we call them, the northern and lights, are there. I don't know if a lot of you know the northern lights and the aurora, and they are really those beautiful lights, and this is where they take place. So this is the place of the ionosphere, and scientists discovered that those ionospheres, those thick layers of ionospheres here, okay, they can transmit information, wavelength, communication. And this is why we send information with that. GPS. We send with we have the GNSS, which is the Global Navigation Satellite System on the ground. So this is how it started, like one century and a half ago. Okay? Someone demand of... I don't understand. Demande pour faire partie de votre vidéo en direct. Je sais pas ce que ça veut dire. So, so the GPS and the so the Global Navigation Satellite System. And those ions, those electrons, if you don't know what is electrons, let me explain to you why I am explaining this, to tell you what happened, a small introduction to tell you what happened. So after explaining the several layers, يعني نحن هلا صرنا هون. So we are in the ionosphere. Okay? So if you have an atom, so an atom is, here we have the atom. Let me change this. So here I have an atom. Okay, we have a proton, we have neutron inside of it, and I have an electron that is rotating around it. So it is not an ideal image of the electron, I will explain. So it is rotating. So when we have the blast of the sun, the flare of the sun that is arriving to this upper layer of the atmosphere, it will take it off, and I have a free electron in the space, So those electrons are floating, and some other ions, yani it is or negative or positive, they are electricity. And I have a lot of things here. It is the number of electrons, quantity, العدد, الكمية, الكم, the number, la quantité. So here I have fluids, like fluids. So they defined some waves, atmospheric waves, that can be wave. So let me define to you the wave. This is a definition to a wave. Those waves has peak to peak. So this is a wave, like the wave in the sea. This is a very defined wave. Okay, so this is the peak. So a very defined wave. Everything is defined now. And كذا. This ionosphere here, كتير حساس, very sensitive, very defined. It can be affected by the sun and by actions on Earth. Like, for example, explosion of volcano. تعرفوا إنه the sun is a heat and it is a shock wave. A volcano from Earth is a heat and it is a shock wave. An explosion of the sun is nuclear and it is a shock wave. Explosion from nuclear is بس لازم يكون كتير قوي. It has to be very, very big. So when you are going to hit something, an atom, you have to do a wave and to excite an atom to take off an electron. So if you are influencing, إذا أنت عم بتأثر على هالميديوم هون, بيصير عندك 1 a wave, second number of electron. يعني you changed the medium. Okay. We defined the story. So how you measure this? You can measure this from the GPS in the sky, because this is measured by radio waves, and you can measure this from the Global Navigation Satellite GNSS on Earth. The group of our friends, Japanese, what was his name? هلا كتبته. let me tell you what is his name. It is from the Hokkaido University, and his name is Kundu et al. Anyway, so those guys. So they did the study, and they found, what did they found? They found that there is 10 minutes after the explosion of Beirut, 10 minutes after the explosion, they found that there is a blast, a wave, atmospheric wave, traveled from here, from the troposphere to the ionosphere in a southward direction with a very specific velocity. Moreover, with a peak wave, they calculated this wave, and then it increased the number of electrons for a specific time in the ionosphere. يعني في from detector بالGPS in the sky and from the GNSS اللي هن موجودين in Palestine and in other place حدنا, they were able to detect number of electron increased بالionosphere and a wave shock that was created, induced because of the blast. So normally هيدي البلاست بتصير إذا صار مثلا from the sun على الايونوسفير. شفنا انه الايون هو بيطلع منه الالكترون اذا اجى بلاست من الصن او فولكانو كتير طالع او انفجار نووي. So the shock wave عملت wave بالايونوسفير. It was very well traced, اسمها N-shape perturbation. And moreover, they were able to calculate the number of electrons اللي زاد and the speed will shape of the wave. هلا it is not catastrophic, يعني ما رح يصير تشتت الدنيا أكتر. It will not rain more or بس it has an influence on the ionosphere. يعني it had an influence. It was after 10 minutes. 10 minutes لأنه for the blast and shock wave to arrive to influence لحتى يصير في propagation on that to arrive to create the ionization ليعمل excitation. You know, when an atom will gain energy, it has to بيطلع من level ل level and the energy is so heavy and so strong, it will take off an electron. So what happens is the energy كانت كتير قوية، سرقت electron، أخذت electron and عملت a wave. يعني قد ايه كان قوي الشوك؟ طلع like several hundreds kilometers، يعني أبعد، يعني مثلا ما بحطوا satellites and it influenced the ionosphere. فوالا هيدا شو اسمه الريزلت، ورح اقولها بس بالعربي. يعني عملت الانفجار، عمل موجة وصلت للايونوسفير بسرعة 0.8 كيلومتر بالثانية، وشافوا انه غيرت المحتوى. سوري عم حكيت بالانجلش، رح اقولها غيرت المحتوى بالكم من الالكترون الموجود بالايونوسفير، واكيد ما بيأثر، وهن اكتشفوها من الجي بي اس والجي ان الاس اس. فوالا، وانا بشكركم انه ان شاء الله اكون جاوبت على هيدا الموضوع. في موضوع تاني كمان اللي هو الانجينيوتي، رح احكي عنه غير مرة لانه بدي احضر فيديوز وصور صغار كتير كتير انترستينج، لانه اول مرة بيستحق الموضوع يكون طويل اكتر. اول مرة بتاريخ الانسانية بيطير. اوكي I will open. thank you. بس بدي اسألك can I have a Samsung, I don't have an iPhone. Can I have a clubhouse? I've been asked. I have a friend from Canada, she asked me also. Okay, so first time in the humanity that we can have something flying on a small few atmosphere on Mars. So I will be talking about this, and I promise I will open a room on Clubhouse soon. If I will do, oh no, I need an iPhone. Okay, I don't have an iPhone, so I have to. I just got a gift, Samsung. Okay, so I see what I will do. Thank you so much, and hopefully for a beautiful subject next time. عن شو اسمه الهليكوبتر on Mars. And until then, stay safe, stay happy, and cheers. Can you share the link? Yes, of course. أنا بحطه عطول على my YouTube channel, Dr. Sirine Naami Astro channel. I will share it here when I will put it. Ciao. Thank you for joining, and see you next time, maybe next week or in 10 days. Ciao.